What to do if you are solving a trig equation and you find that it has more than one trig ratio in it? Well, use your trig identities that you know as you acquire them. Now, these sorts of problems often require a little bit of thinking outside the square. We've got an example here where we've got cos x and sin x in the same equation. We know x is between 0 and 360, and yet we can't really start thinking about which quadrant x might be in because we don't know enough about it. So what do? Well, look for clues. I see this 0 here and I think, if I could factorise this side, maybe I could have something times something to make 0, I'd be able to tell that one of those things would be 0. But these aren't easy to factorise, so I dismiss that idea pretty quickly. So the only other thing that's really left to me is to put one thing on, to subtract something from both sides. So let's start by subtracting the simplest thing there, the sin x. If we have root 3 cos x on its own, it will be because we've subtracted sin x from both sides, and that gives me this line. Okay, now if I've got cos x and sin x here, if I actually divide both sides by cos of x, I'll have sine over cos, and I'm thinking that'll give me tan, so that's quite helpful. So if we divide this side by cos of x, that will remove the cos x from this side, and dividing this side by cos x gives me sine x over cos x. I've still got that negative out the front. Now we could basically flip the signs here. We could say that negative root 3 is the same as sine x over cos x. At this point I'd probably have just written tan x down straight away, but we're trying to just do things one step at a time so we don't lose you. Sine x over cos x is tan x, so I'm going to write that on this side now. And now I've basically made a starting point to do what I usually do when I solve a trig equation, is I start thinking now about which quadrant x could be in. Now if tan is negative, think through all stations to central. Tan is positive here and here, so it'll be negative in the second and the fourth quadrants. So we want second and fourth quadrant. Alright, so think about tan of something is root 3. Now from our table of exact values, we know tan of 60 degrees is exactly root 3. So the related angle is 60 degrees, but we've got to put it in the second quadrant and in the fourth quadrant so that it fits into this domain. So putting 60 degrees over here, we need to do 180 minus 60. So x will need to be 120 degrees. And to put it in the fourth quadrant, we need to do 360 minus 60, and that will give us 300 degrees.